So, number one, what is a residual? Go ahead, Paige.
The distance between fitted and actual value.
The distance between the actual value and the fitted value. If it is positive, then the actual value is bigger than the fitted. In other words, the fitted value is underestimated. If it is negative, the fitted value is an overestimate. The chances that they would be equal to each other in practice is very, very low. It does happen occasionally. Number two. Two variables have a positive linear correlation. Is the slope of the regression line for the variables positive or negative? Positive linear correlation, I'd like to know if the slope is going to be positive or negative.
Positive.
Positive, easy question. How do we predict y values once you have the regression line? So I know the value of a hat, I know the value of b hat. All I have to do is plug in an x value to predict a y value, which is why we call x to be the predictor. Number 5. So I told you about the prediction, and I told you how to get a predicted value by plugging in an x value. So number 5 wants to know if you have to predict the y values using the regression equation that you obtain, what should be true about the correlation coefficient? The answer is in a hat. In a hat, the estimate is r multiplied by sy divided by sx. Matthew?
I was going to say, since you're basically just like estimating the r value, that the line of estimate actually correlates with the data.
So the line of best fit should actually correlate the data. In other words, the value of r is positive, could be positive or negative, but it cannot be 0. If it is 0, then what is the point in predicting y using x? Because y and x are not related at all. So the value of r must be non-zero. Number 6, I'll give you the reason as to why. Anytime we predict y using x values, whatever x value that we use should be within the range of x values that we have, that we observed. Sometimes it could go slightly out of the range, but we want it within the range of x values that we observed. Why is that requirement needed? Matthew?
They like outliers essentially, because if you start going outside of what you relatively know from the data, you would know like how far off your line is, or if there are any outliers on the expected data.
Exactly. Suppose I measured, say, the amount someone spent on lunch and correlating that with something else. And I measure somewhere from $2 all the way up to $20. It would be incorrect for me to predict for a value of x equals $40, correct? Because whatever that I observed can only explain for x values between $2 and 20. It is not rational for me to use that information and predict as to what happened when x is equal to $40. Practically, it doesn't make sense. Okay, so hours spent studying and test scores. So the x values range from 0 all the way up to 8. There are three different x values that are the same because we have three students who said they spent 5 hours, but that doesn't mean that they would have the exact same test score. It is going to vary. So one person has 69, others 73, the last one 75. First thing to do, enter the data. List one by default would contain the x values. So, second vote. Last time I showed you how to find the scatter plot using the calculator. My plot is on. I see nothing because I've got to use Zoom 9. And that is my data. And you can see at 5, I've got a bunch of points really close to each other. Do we believe that there is a correlation, a linear correlation between the hours spent studying and the test? Apparently so. Now we want to know the fitted model. So press start. Go over to calc. Of all the options there, which one should you pick?
4.
Number 4. All the calculators you can hit enter as long as you have list 1 x values and y values in list 2. Newer versions of the calculator, perhaps you should specify L1 for x list and L2 for y list. And that is my fitted model. The value of A hat is 7.45. The value of B hat is 37.449. Good. My fitted model. So based on the data that I collected, I obtained a line of best fit where the slope is 7.45 and the intercept is 37.45. Here is a question. If a student did not study at all, in other words, 0 hours spent studying based on the model, what score could we expect? 40, using the fitted model. 37.45. Yes. But in this case, 0 is there. We did a good estimate. Let's say someone spent 3 hours, right? Did we observe 3 hours in the data? No. But is it within the range of data that we observed? Yes. So how do we find the test score corresponding to 3 hours? Plug in 3 for x, and what did we get? 59.8. Great. How about 6.5? Can I plug in 6.5?
85.8.
85.88. And 13 hours.
You can't do so.
It is outside the range of data that we observed, so can't be 4.5 hours.
70.975.
70.97.
That's
Okay.
up front.
What about 6.5 again? 85.88, okay. Sounds about right. Do we have a strong linear correlation based on the data? Yes, no, maybe. Have 0.9684. And is it positive? The more time you spend studying, the higher your test score. So yes. In addition, the slope A is positive, which indicates an increasing line. Before I show you something else, how would we interpret the slope? What does it mean? A value of 7.45.
Positive slope.
Yes, that is true. But if you have to explain this to someone, how would you explain? 7.45 is positive. It's going up. I know both things, but what does that number mean? 7.45.
For every hour, the percentage goes up by around 7.45%.
It's the score, not the percent, right? So for every hour that you spend studying, your score is expected to go up by 7.45. Does that make sense? So study for your exam seems to be true. Last time I showed you how to get all the fitted values. All we have to do is type in our equation in there, but we're supposed to put L1, so 7.45 instead of X. The X values are in list 1, so second 1 plus 37.45. Good. The actual Y value is 40. The fitted value is 37.45. Did it estimate it really well? Kind of okay. Yes. How about 51? The actual value is 51 for 2 hours. The estimated value is 52.35. That said, what is the residual for the second observation? 1.35. How did we get that, Nick?
So I subtracted the
Actual value minus the fitted, positive or negative 1.35. Negative. So 51 minus 52.35, so negative 1.35. Good. Did we do labs and stuff? Chemistry, physics, one of those. In labs, when you get the results after an experiment, typically they would ask you to plot the results. Yes. When you plot using Excel, on the top right corner, there is R squared. Yes, do we remember? What does that R squared mean? R squared stands for, that in there.
regression squared.
True, regression squared. But R squared stands for coefficient of determination. That simply tells you how well your model is predicting the variations in Y for any given X. In this case, it's about 93.79%. So could I say that my model is good at predicting? 93.79% is not bad. If that value happened to be 40%, do you have a good model? Absolutely not. So R squared is the coefficient of determination, and R is the linear correlation coefficient. And of course, they are related to each other. So the slope is related to R, the coefficient of determination is also related to R. All in all, R is quite important in terms of linear regression.